Hello, welcome to Emmanuel Maths Academy. So we have a problem on the board. Given y equal to sine inverse of x, find the y, the x, right? So, but first of all, we need to apply something before going straight to our differentiation, because we cannot differentiate this the way it is. Then we need to get rid of what? Minus 1 before solving. Remember your law of indices that A inverse 1 is equal to 1 over A in your law of indices. So you need to apply this principle first. You now solve what? Using implicit differentiation. Now, let's get to the solving, right? So, solution. So, we are given that our y is equal to sine inverse of x, right? So, it's the same thing as y equal to 1 over sine dot x. You now cross multiply. When you cross multiply, you have what? Sine y equal to x. With this, you now solve using what we call implicit differentiation. Now, if you differentiate sine y with respect to x, you have what? Cos y. You now have dy dx. This is the implicit here. Equal to, if you differentiate this with respect to x, you have what? 1. Right? Then you cross multiply again, you have dy over dx equal to 1 over cos y. You can just say dividing both sides with the coefficient of dy dx, right? Which is what? Divide this side with cos y. This will cancel this. You now have dy dx equal to 1 over cos y, right? Then, remember in your trigonometric identity that sine square y plus cos square y is equal to 1. Remember, this can be anything. It could be y, it could be x, it could be a or b. But we are just using y because what we have here is y, right? You now make cos y the subject of the formula. If you make cos y the subject of the formula, you have what? First of all, you have the power. Cos square y equal to 1 minus sine square y. You now take the square root of both sides. You have what? Cos square y square root equal to 1 minus sine square y. Because you are trying to get rid of the power here. You have cos y equal to square root of 1 minus sine square y. Right? You now substitute this what? Into this place. Let's just call this equation star. Let's just call it star. So you now substitute the value of cos y in star. Here you have dy dx equal to 1 over cos y. So we'll be replacing cos y with what we have here, right? So we have square root of 1 minus sine square y, right? Recall that our sine y is what? Our sine y is something. Sine y is x. Recall. You can say recall that sine y is equal to x. Hence, our dy dx is equal to 1 over square root of 1 minus x. But we have square here. You now have your square. Now, this is your dy dx.